Are able to see my screen, right? Yes. Are you people able to see my screen?
Yes, ma'am.
Okay, fine. So in the last class, we have seen how to generate PN sequence, right? So I'll have a particular circuit. Based on that circuit, the PN sequence will be generated. So this we have seen in the previous class. So here, what is happening? If I want to design the PN sequence generator, then I need to have the flip-flops. Okay, and here will not give any input. From the output it will be fed back as an input. Okay, and then what we are doing, we are circularly shifting it, and we are finding the output PN sequence. So here in this example I've shown you clearly how to get the PN sequence. Okay, now after we got the PN sequence, this PN sequence will satisfy some properties. One such property is nothing but the balanced property. Balanced property you need to check in such a way that whatever PN sequence you get, in that PN sequence the number of ones will be 1 greater than the number of zeros. If I have zeros as 8, then my number of ones will be 9. Okay, so one extra bit will be there with respect to 1. Okay, so that is what the balanced property is. Run property, here you need to find out the number of runs. Okay, number of runs you need to find out. Okay, so if this is satisfied, then we can say that the run property is satisfied. Okay, and how many runs, length of each run will differ. Okay, so if you want to find how many such runs are available with that particular length, that can be calculated by taking 1/2 power n into total number of runs. Okay, and where this n indicates the length of the run. Okay, the length of the run. Okay, next comes the autocorrelation property. So we have this is what the equation to find the autocorrelation function. Okay, once you know the autocorrelation function, the equation, what you can do is you need to find out the value for different lags. So different lags in the sense I have taken d is equal to 0, d is equal to 1, d is equal to 2, like that you have to take. Okay, so when you can check here d is equal to 0, you'll get as c of n, which is nothing but cn square. Like see in the equation you'll get as cn square. Cn square value will be always equal to 1. Okay, cn square value will be always equal to 1. Okay, so then comes r of 1, you need to find r of 2, r of 3. If you just find all the values, r of 0, r of 15, r of 30, r of 14, 45, all these values will be equal to 1. Okay, so you have y for r of 15 you are getting as 1 again, because when you circularly shift again, it will r of 0 value, c of n equation. Whatever c of n equation, you will have c of n values, like I have taken as -1, something like this. No, whatever you get here, the same will be there for r of 15 also. Yes, c of n will be same. Whatever you have here, the same will be here also. Okay, so that is the reason r of 0, r of 15, r of 30, r of 45, all these values will be same. Okay, and rest all values, r of 1, r of 2, r of 3, so on until r of 14, that will be equal to -1/15. So we have already done with an example. You can now what I have done here is I have just plotted the autocorrelation function. Okay, so for the autocorrelation function, when the delay or the lag is 0, okay, its value is maximum, and after that 1, 2, 3, whatever I have taken, its value is -1/n. Okay, 1/n. Particularly if you just take for your sequence 4 using whichever we have generated using 4 flip-flops, it is nothing but 1/15. Okay, so 1/15. So you from this you can see that r of 0, the value is 1. R of 1, it is -1/15. So r of 1 I'm getting when we are circularly shifting c of n to c of n minus 1. Okay, so for that what is happening, the autocorrelation function value is -1/15. So there is lot of difference. So from this I can say that you can use the same autocorrelation, same PN sequence Okay, for different uses. Same PN sequence can be used for different uses. Okay, so this is what the autocorrelation property. So we have already seen all that. Now we'll go with the problem. Okay, now we'll go with the problem. Okay, next, here you just note down the problem. What you have to do, I will let you know. Okay, so take the problem. Okay, in the problem, it is mentioned that a three-stage. What do you mean by three-stage? I'll be using three flip-flops here. Three-stage shift register. Okay, with linear feedback shifting generates the sequence 0 1 0 1 1 1 0 0 1 0 1 1 1 0. Okay, this is what the sequence it is generating by the three-stage shift register. Okay, in this the first question is determine the period of the given this will just proceed of the given sequence and then verify the properties. Verify the properties of PN sequence. Okay, so this is what the question given. What you need to do first, you need to determine the period. Okay, it is period of the given sequence. So here he has given this sequence. It is nothing but the infinite sequence. See, this sequence will continue like that. Okay, so what is the sequence he has given? 0 1 0 1 1 1 0 0 1 0 1 1 1 0, like that it is continuing. So can anybody tell me what is the period of this particular signal? Can anybody tell me what is the period of this particular signal? So how will you find the period? That is what my first question. How will you find the period? How will you find the period? Can anybody tell me how to find the period here? How to find the period? PN sequence, whatever is generated is a periodic sequence. So how will you say that the sequence is periodic or not? Can anybody tell me? Hitesh? Somebody is about to answer. I'm sorry, you can answer me.
If repetition is there, it's periodic.
Yeah, if repetition is there, it is periodic. So, can you see any repetition here?
After 1110, it starts repeating.
Yeah, after 1110, it is repeating. The same thing, it is repeating. So, this is your PN sequence now. And what is your N value? Period. What is the period of this? What is the period of this? Period is number of bits present. How many bits are here? 1, 2, 3, 4, 5, 6, 7. 7 bits. Okay, n is equal to 7. So, and your PN sequence is nothing but 0, 1, 0, 1, 1, 1, 0. See, this is what your PN sequence. I could determine the period. This is nothing but the period of the given sequence, and I could also find the PN sequence. Okay, so this is what your PN sequence. Now, I need to, this is what my A part. B part, I need to verify the property. So what is the first property? Balance property. Okay, what is the balance property? Number of ones will be equal to, how many number of ones you have? How many number of ones you have? Quickly, fast. Anybody can unmute. You can see my screen, right? Are you people able to see my screen?
Yes, ma'am.
Okay, so can you tell me how many number of ones are there?
4.
4 ones. Number of zeros?
3.
3. So if you just observe, the number of the number of ones will be equal to the number of zeros plus 1, right? So I have 3 zeros, 3 plus 1. So it is satisfying the balance property. Okay, now second property. Second property is run property. Run property. Okay, so run property, again I'll take the PN sequence. The PN sequence what I have is 0, 1, 0, 1, 1, 1, 0. Okay, so this is what the sequence I have. So is it satisfying the property? What is that in the run property, what I need to study? I need to find out total number of runs, right? Yes or no? Yes, I need to find total number of runs. How will you find total number of runs? N plus 1 divided by 2 will give the total number of runs. This is what the formula we have, right? Just check it. Run property. Total number of runs is equal to n plus 1 by 2. Okay, so here in place of 1, n value is nothing but 7. 7 plus 1 divided by 2. It is nothing but 8 by 2. 8 by 2 in this is 4. Okay, so I need to get 4 runs here. So let us check whether I am getting 4 runs or not. If I am getting 4 runs, it is valid PN sequence. If it is not, I have to see what I have to do. Okay, so just see here runs. How will you find runs? The continuous ones or continuous zeros can be taken as a run. So this is the first run, this is the second run, this is the third run, this is the fourth run, this is the fifth run. Is it satisfying the runs property? Actually, I have to get 4 runs, but how many runs I am getting? How many runs I am getting? How many runs I've got here? Run is nothing but continuous ones or continuous zeros can be taken as one run, right? So here I have only 1 0, so I've taken it as first run. Here I have only 1 1, so second run. Here I have 0, so third run. Here I have not taken only 1 because I have continuous ones 1 2 3. So all ones, that is considered as fourth run. Here I have considered again after that 3 0 3 ones I have 0. So I have taken it as fifth run. Okay, so here actually according to the property I need to get 4 runs, but how many runs I've got? How many runs I've got total? Nisarga? Yogesh?
Ma'am,
Answer me, how many runs you have got here from the PN sequence?
4, ma'am.
4 is according to the formula, but from the sequence how many runs you have got?
5, ma'am.
5. Okay, 5 I've got. So 5 is not valid. So it is violating the rule or the property. Okay, I have to get 4, but I'm not getting 4 runs. Instead, I'm getting 5 runs. So what I can do is I will shift. See, as I have already mentioned that if you by shifting one bit circularly, you'll be able to generate the new sequence. So what I'll do here, I'll I will rotate it circularly like this. From here, I'll bring it here. So let me check what happens. The new PN sequence will form. The new PN sequence will form. Okay, let me check what will happen there. It is like 0, 0, 1, 0, 1, 1, 1. This is what the new sequence I've got. Again, we'll check the number of runs. Okay, so 0, 0, 1 run, 1, 2, third run, fourth run. So from this newly formed PN sequence, am I able to get runs, 4 runs or not? Am I getting 4 runs or not? Are you people understanding what I'm trying to say here? See, initially they has given me the PN sequence, some sequence he has given, okay, which is generated by the shift register. Okay, that sequence I have taken, and here he is asking you to find out the period of the given sequence. So how will we find the period? If the same thing is repeating until that point, will take as one period, right? So this is the fundamental period. So if you count the number of bits there, you'll get the number of the period of that particular sequence. So from this, after this point, it is repeating again. So this can be considered as a PN sequence with the length 7. Okay, so 7 is nothing but the period of the PN obtained PN sequence. Now for this, in the question, he is asking you to verify the properties. Okay, the such property is nothing but the balance property. Okay, according to the balance property, the number of ones should be equal to the number of zeros plus 1. In the sense, like how many number of zeros you are getting, it should be 1 greater than that many ones you need to get. So that if you just check here, I have 4 ones and 3 zeros, so it is satisfying the balance property. Then comes the run property. Run property, you need to find out how many runs are present in the given PN sequence. So if you just find it is 4. Okay, now what I'll do from the obtained PN sequence, let me just check whether I'm getting 4 runs or not. So if you just check, I'm getting 5 runs. Okay, so since it is not obeying the property. Okay, so what you can do is you can generate the new sequence. How you can generate the new sequence? Just shift the last one to the first. Circular shifting the data. Okay, the last one I'm shifting it to the front, and I'll check whether I'm able to get 4 runs or not. So if you just observe 0, 0, continuous zeros I have, so that will be considered as one run. And here I have only 1, 1, so second run, third run, fourth run. So I'm getting 4 runs. So this could be a valid PN sequence. This could be a valid PN sequence. Okay, now I need to find how many runs are available with a particular length. Okay, so n is equal to 1 indicates the length. So 1 by 2 power n into total runs. Okay, will give me the number of runs that are available with length n is equal to 1. Length n is equal to 1. Okay, so 1 by 2 power n into total runs. Okay, that is nothing but 1 by n is equal to 1. So 2 power 1 into total runs is nothing but 4. So 4 by 2 it is 2. So what are the runs? What are those runs? With length is equal to 1. I have got 2 runs. Okay, 2 runs are available with length is equal to 1. So this is this contains 2 bits, here 1, here 1, so 2 comma 3. So I've got 2 runs with that particular length. Now I need to take n is equal to 2. N is equal to 2 in the sense 1 by 2 square into total runs, it is 4. 4 by 4. 4 by 4 in the sense 4 by 4 in the sense it is 1. Okay, so 1 run is available with length 2. And what is that run? From the sequence, it is the first run. The first run contains 2 bits. Okay, and here I cannot take n is equal to 3, but I can take n is equal, when n is equal to 3, I need to add all the total number of runs until now. So 2 plus 1, it is 3. 3 minus, total number of runs minus the runs obtained in the previous cases. Total number of runs is 4. 4 minus 3, it is equal to 1. So with n is equal to 3, I should get 1 run, and the run number is 4. Okay, run number is 4. This is how you need to verify the run property. Anybody have doubts here? Please let me know. Okay, then this is the second property. So what is the third property? Third property is autocorrelation property. Autocorrelation property. This also I need to check whether I'm getting the periodicity or not, periodic autocorrelation function or not. So autocorrelation property. Okay, and you should also plot it. So the generalized equation is R of D is equal to 1 by n summation n is equal to 1 to n C of n into C of n minus D. C of n minus D. So first let me take D is equal to 0. D is equal to 0 in this sense, so you will have R of 0 which will be equal to 1 by n. N here is nothing but 7. Summation n is equal to 1 to 7. C of n minus 0 it is n. Okay, so it's nothing but 1 by 7 summation n is equal to 1 to 7 C square of n. Okay, so let me just take the given data, the PN sequence. PN sequence is nothing but what is the PN sequence I've got? Can you tell me the PN sequence which I've got? 0, what is it? 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1. This is what my PN sequence. This is what my PN sequence. For this, the C of n is nothing but representing it in the bipolar form. Bipolar n as 0, minus 1, 0, minus 1, 1, 1, 0, minus 1, 1, 1, 1, 1, 1, 1. Okay, so this is how we will represent it. Okay, so C square n. See, if I want to find R of 0, then I need to find C square n. So square this terms. So minus 1, 1, minus 1, 1, 1, 1, minus 1, 1, 1, 1, 1 square, 1, 1 square, 1. Okay, so this is what your Cn square. Summation n is equal to 1 to 7. C square of n will be equal to 1 plus 1 plus 1 plus 1 7 times. So it is nothing but 7. So finally your R of 0 is nothing but 1 by 7. 1 by 7 and this value is nothing but 7. Okay, so its value is 1. Okay, so this is what your R of 0 value. In the same way I need to find R of 1. It means that when D is equal to 1, D is equal to 1 in the sense R of 1. R of 1 is equal to summation 1 by 7 summation n is equal to 1 to n C of n into C of n minus 1. N minus D, in place of D you have 1. Okay, so this will be equal to okay, so what I need to do, I need to take C of n is nothing but the sequence, whatever I have represented, the bipolar representation of the PN sequence, that I need to take minus 1, minus 1, 1, minus 1, 1, 1, 1. Now C of n minus 1. So C of n minus 1, if I want to get it, I need to shift it. So minus 1 will come here, this minus 1 will come here, 1 will come here, minus 1 will come here, this 1 will come here, this 1 will come here, and finally this one, the last one, will go to the first. Okay, so this is what will happen in C of n into C of n minus 1. Now I need to find C of n into C of n minus 1. Minus 1 into 1, minus 1. 1, minus 1, minus 1, minus 1, 1, 1. If you add all this, summation n is equal to 1 to 7 C of n into C of n minus 1. If you add this entire thing, I'll get as minus 1. Okay, so finally your R of 1 will be equal to 1 by 7 summation n is equal to 1 to 7 C of n into C of n minus 1. So this will be equal to 1 by 7, and you know that this entire thing value is nothing but minus 1. So it will be equal to minus 1 by 7. Okay, the R of 1 is minus 1 by 7. In the same way, you need to calculate for D is equal to 2. So R is equal to 2. R is equal to 2. Again, you have 1 by 7 summation n is equal to 1 to 7 C of n into C of n minus 2, because D value is 2. Okay, so again take C of n. C of n is nothing but minus 1, minus 1, 1, minus 1, 1, 1, 1. Now I need to shift 2 bits to the right. So this minus 1, this minus 1, this minus 1 will come here, this minus 1 will come here, this 1 will come here, this minus 1 will come here, this 1 will come here, and this 1 will go here. So this is here C of n minus 2. Okay, now again you multiply them. Okay, so minus 1 into 1, minus 1, minus 1, minus 1, 1, 1, minus 1, 1. Okay, so 1, 2, 3, 3, minus 1, minus 1, minus 1, minus 1, it is minus 4. So this is equal to minus 1. Okay, so I can write it as summation n is equal to 1 to 7 c of n into c of n minus 2. Okay, c of n minus 2, its value will be equal to minus 1. So finally r of 2 value is equal to what is it, 1 by 7 summation n is equal to 1 to 7 c of n into c of n minus 2, which is nothing but 1 by 7 into minus 1, so which is nothing but minus 1 by 7. So this values will be same even if you similarly find for r of 3, its value will be equal to minus 1 by 7 only. R of 4, its value will be equal to minus 1 by 7 only. R of 5 value will also be equal to minus 1 by 7. R of 6 will also be equal to minus 1 by 7. Now coming to R of 7. R of 7 in the sense, what will happen? 1, 2, 3, 4, 5, 6, 7. Okay, so 7. Okay, from whatever you have here, again it will repeat once again. So again you will have as minus 1, minus 1, 1, minus 1, 1, 1, 1 as. So here C of n is this one. C of n is minus 1. What is it? Minus 1. 1 or minus 1. Minus 1, minus 1, 1. Minus 1, 1, 1, 1. Okay, this is your C of n. If you take C of n minus 7, because your D is equal to 7 here, it will be again the same. Minus 1, minus 1, 1, minus 1, 1, 1, 1. Okay, so this will be the value even when we are shifting, because 1, 2, 3, 4, 5, 6, 7. So whatever 7 terms you have, all those should come here. So that's why it will be the same. Okay, so again this is nothing but r of 7 will be nothing but this entire thing, if you multiply and add, it will be equal to 1. Okay, c of n into c of n minus 7, and when n is equal to 1 to 7, its value will be equal to 7 itself. So r of 7 is nothing but 1 by 7 into this one. This one is nothing but 7. So this will be equal to 1. So r of 7 value will be equal to 1. Then again r of 14 value will be equal to 1. R of plus 7, 21 will be equal to 1. And that's how it goes. Okay, so this is satisfying the property, autocorrelation property. Okay, now coming back to r of plotting r of d. This is d versus r of d, the lag versus the autocorrelation function. So at 0 at the maximum value, and here it is minus 1, plus 1, 2, okay, 2, 3, 4 like that. Here I will have 7 like that. I will have minus 7 here. Okay, so the graph will be like for 1 it is minus 1 by 7. So your graph will be in this way. Okay, and after this it will be constant. Here this side also it will be constant. Again you will have maximum value at minus 7, and again it will decrease. Here also at 7 you will have the maximum value and it will decrease. Okay, so that is what the autocorrelation property is. Okay, so in the exam they may give you the sequence and they may ask you to find the period, and they may also ask you to verify the properties. Okay, so this is all related to the generation of PN sequence. Hope this is clear to all of you. Is it clear to all of you? Are you all listening to me? Deepshi, are you there?
Yes, ma'am.
Are you listening to me?
Yes, ma'am.
Are you understanding? You didn't understand, Deepshi?
Understood, ma'am.
Okay. Okay, so this is how the generation and the detection of generation of PN sequence and how we are verifying it. Okay, so here we have seen the generation. Okay, now what is the main use of generating this PN sequence? Okay, the main use of this generating this PN sequence is you need to modulate the basic signal. Okay, B of t signal. B of t signal is nothing but you have BK will be like 101 like that, right? So B of t is nothing but using the NRZ bipolar, we represent 1 as 1 only and 0 as minus 1. So that is what your minus 1 here, 1 here. So that is what your B of t signal. Okay, so what I need to do here, whatever C of t sequence I'm getting. Okay, so this is my original signal. Now what I need to do, if I want to provide security, I need to spread this signal. Okay, spread this basic signal. So to spread this basic signal, I'm using C of t, which is nothing but the PN sequence. PN sequence is nothing but the C of t sequence. So here I'm using this C of t sequence to spread the signal. Okay, once I spread it, okay, how I'm spreading the transmitter, I'll show you. So how I'm spreading and how I'm de-spreading, we'll see. Okay, so you, if you just recall the block diagram, let me just go to the block diagram, the initial. Here what we are doing, we are modulating the signal. Okay, whatever signal we are getting here, B of t signal, that we are modulating. Okay, how we are modulating? Using this C of t sequence. C of t is nothing but the pseudo noise sequence. Okay, using this we are spreading it. Okay, so here at the transmitter end, we are spreading the signal. Spreading the signal. Okay, so how exactly we are spreading, I'll show you. Okay, then what we are doing, we are transmitting it through the channel. Okay, from the channel it will be given to the demodulator. What the demodulator has to do, here I'm spreading the signal and I'm sending it. So at the transmitter end, what it has to do, it has to de-spread the signal. Okay, so I've already mentioned the condition for spreading whatever PN sequence you are using. The same PN sequence should be used at the de-spreading also, at the receiver for de-spreading also. Okay, so that is what the condition. With that only you'll be able to estimate the signal correctly. Okay, so here what I need to do, I have first at the transmitter end, I have to modulate it by using the PN sequence, and at the demodulator again using the same sequence, I have to demodulate it or de-spread it. Okay, de-spread it. Okay, so now let us go with the block diagram. See here, it is nothing but the direct sequence spread spectrum. Spread spectrum. Direct sequence spread spectrum, which in short we'll call it as DSSS. DSSS is nothing but the direct sequence spread spectrum. Okay, so here what we are doing, we are directly taking the C of t signal and we are B of t is directly modulated by C of t signal and we are transmitting it through the channel. Okay, so here as I've already mentioned, so I'll have the let me just give you the transmitter diagram. It will have B of t signal. Okay, maybe whatever output you are getting from the channel encoder or what directly whatever data your digital data you have, that I'm representing it with B of t. B of t is nothing but, as I've already mentioned, B of t value will be equal to plus 1 if bk is equal to 1, or it will be minus 1 if bk is equal to 0. Okay, so that is what here B of t. Then what I'm doing, I'm giving it to the product modulator. So to the product modulator, the other input is C of t. Okay, C of t value is nothing but it will be equal to plus 1 if Ck is equal to 1, and it will be equal to minus 1 if Ck is equal to 0. What is this what is this Ck? Ck is nothing but this PN sequence. Whatever we have generated here, the PN sequence, this is nothing but a Ck signal, Ck. Okay, this I am writing it as C of t here. Okay, C of t. C of t value will be equal to plus 1 if Ck is equal to 1, and C of t value will be equal to minus 1 if Ck is equal to 0. So using this, I am this B of t and this C of t. C of t is nothing but the PN sequence and B of t is nothing but the data sequence. This I am giving it to the product modulator, so my output will be M of t. M of t is nothing but B of t into C of t. B of t into C of t. Okay, so here this M of t, whatever M of t I am getting, it is a spreaded signal. Spreaded signal. Okay, understand this properly. This is said to be the spreaded signal. Okay, and here I'm not modulating the signal, I'm just transmitting it like that only. Okay, so if I'm transmitting it like that only, it is used for short range communication. For the long range communication, you have to definitely go with the modulation techniques. Okay, so here whatever we are seeing, it is just for the short range communication. So this M of t is nothing but B of t into C of t. Okay, and here C of t, okay, the PN sequence Okay, PN sequence is represented with the C of t, right? So this PN sequence, okay, this PN sequence, what happens here is, let me just assume that I have, let me just take the waveforms for C of t, B of t and all, and I'll explain you. So let me first take B of t signal. B of t signal, let me take as 1 and 0 only. Okay, so 1 and 0. 1, this is my 1, this is my 0. This is my 0. It is time t. This is my 0. 1 will generally represent it as +1. 0 will generally represent it as -1. Okay, so this is what the bit sequence I have. Okay, now the PN sequence is generated. Okay, so the PN sequence, let me take the same one, whatever we have taken before. What is that? Example we have taken, no? What is that? 0, 0, 0, 1, 0, 1, 1, 1. This is what my PN sequence. Okay, so whatever you have one bit is from here to here TB. This is your 2 TB. Okay, so within TB seconds, I need to have the PN sequence. Complete PN sequence should be represented from 0 to TB. Okay, in the same way from TB to TB, again you know that the PN sequence is periodic. Okay, so again I'll have as 0, 0, 1, 0, 1, 1, 1. Okay, and here since like each bit of this C of t is said to be the chip. Okay, chip or bit, anything you can call. Okay, so generally we call here for spreading the signal, we are using this PN sequence, and this PN sequence should be within 1 bit duration of the actual data. The PN sequence, the complete PN sequence should be there. Okay, so that is what your C of t signal. Let me draw the signal first and I'll explain you. Again, the C of t is also using the NRZ bipolar only. Understand this properly. Okay, so 1, 0, 0 will be represented with minus 0. Then again 1. So this is +1, this is -1. 1, next to 0, next to 1, all ones. So +1. Again I have 0, -1. Oh, sorry. Again I have 0, so -1, 1, I have +1, 0, -1, 1, +1. Okay, so here if you just observe, this is nothing but each bit in the PN sequence is said to be the duration of that is given by TC. Here it is given by TB. TB is nothing but the bit duration of data sequence. Whereas your TC is nothing but the chip duration. So within 1 bit period you need to get 7 bits. Okay, and each bit duration is represented by TC. Always your TB should be greater than TC. Okay, TB should be greater than TC. Okay, and TC within 1 TB you need to have the complete PN sequence. One complete fundamental sequence should be available. Okay, so this is what TB and TC. Okay, 1 by TB. So how will you calculate frequency? Frequency is equal to frequency for this the data will calculate as FB is equal to 1 by TB. So FB is more in the sense TB is more in the sense FB will be less. Okay, FB will be less. Now TC TC, in the sense FC is equal to 1 by TC. Okay, TC is less. Okay, if you just observe, this much is here TC, whereas TB is, the duration of TB is more when compared to TC. So TC is less in the sense FC. What is happening to FC? It is increasing. Okay, so increasing the frequency, we call it as it is spreading. Okay, so that's what it means. Okay, so if you just observe, B of T is said to be the narrow band signal, and C of T is said to be the wide band signal. Okay, this is B of T is a narrow band because the spectrum, the frequency value or the bandwidth value is less here. If you take the PN sequence, the bandwidth is more. Okay, so this we'll call it as B of T, we'll call it as narrow band signal, and C of T we'll call it as wide band signal. Okay, so hope this is clear to you. Is it clear to you? You want me to repeat anywhere? Do you want me to repeat anywhere?
No, ma'am.
Okay, fine. Now I've got B of T signal and C of T signal. Now what I need to do? I need to get M of T. Okay, let me just take from the C. I'll erase this portion. I will erase this. Here I have just explained you what is narrow band signal and what is wide band signal. So here what we are doing, using the PN sequence, I will be expanding it. Let me just check whether I am able to expand it or not. So it's a continuation. Here only let me just draw. Okay, now what I have done, I have taken B of T, I have taken C of T, and I have multiplied both of them so that I am getting M of T. And M of T, I am saying that it is spreaded because of the C of T signal. Okay, so let us see what output I'll get here. So if you just observe, I'm multiplying this B of T signal, with C of T, in the sense from here to here. If you just observe from here to here, I have 1 as the amplitude here, but here I have -1. So 1 into -1, it will be -1 only. So I'll get as let me draw the dotted lines once again. Continuation only. Okay, so when you are plotting, you plot it as continuous only. Okay, so see here. First I have from here to here, if you just take from here to here, I have +1 and here I have -1. So +1 into -1, I'll get as -1 only. Then again here I have -1 and here I have +1. So it will be -1 only. Okay, -1. Here I'll have +1. Okay, let me take different color. So from here to here it is -1. Again check here. So from here to here, this is 1 and even this is 1. 1 into 1, it will be 1 only. 1 only. Okay, then again -1, 1. Okay, so it will be -1. Again 1 and here also it is 1. So it will be +1 until here. Okay, next. Here you have to just note it down. See here. My B of T value is -1 here, and here also it is -1. Minus into minus, it will be +1. So it will be +1 only. Again -1 here, -1 here, minus into minus +1. So it will be +1. Here it is +1, here it is -1. Plus into minus, it will be -1. So -1 will be like this. Again -1 here, -1 here. So it will be +1. So it will be like this. Then again this is +1 and this is -1. So all this for all the 3 bits, +1 into -1. So it will be -1. So you'll have like this. Okay, so if you just observe, this is nothing but the chip duration TC. This is nothing but the chip duration, and until here is nothing but your TB. Okay, so if you just observe, this is nothing but your M of T signal. So if you just observe the M of T signal, the bit duration or the chip duration is TC. Okay, so using your C of T, we are able to spread it now, because you know that TC is small. For this M of T, TC is small, then your F frequency for this M of T will be more. How do you calculate it? Frequency of M of T will be equal to 1 by TC. So TC is small, from here to here is your TC is small, so the frequency of M of T is more. Okay, so this is what is happening at the transmitter end, and if you observe, using the C of T signal, we are able to spread the signal. Okay, so this is at the transmitter end. So in the same way, we have to calculate it at the receiver end as well. Okay, so that I will show you. And before that, I just want to introduce one more parameter here, which is said to be the processing gain. Okay, processing gain is nothing but it is denoted as PG. PG is nothing but the processing gain. Okay, and this processing gain normally it is defined as the ratio of TB by TC, the ratio of the bit duration divided by the ratio of the chip duration. Ratio of bit duration to the chip duration will give you processing gain. Okay, so from this I will just try to see, I will just try to find out another relationship. So here I have TB by TC. What I can do is I can take as 1 by TC divided by 1 by TB. See, this TC I have taken up and this TB I have brought down. So 1 by TC divided by 1 by TB. Okay, 1 by TC is nothing but bandwidth of bandwidth 1 by TC is nothing but the bandwidth after spreading the signal, right? So this M of T is spreaded. Okay, so bandwidth of this is nothing but 1 by TC. Okay, so this 1 by TC I can write as bandwidth of spreaded signal. Okay, how we are spreading? Using PN sequence to the bandwidth of data sequence, or I can write it as bandwidth after spreading. Okay, I'll just write it in another way. Bandwidth after spreading, okay, is 1 by TC. Bandwidth before spreading is 1 by TB. Bandwidth before spreading is 1 by TB. Okay, and you know that see the number of if you just observe the waveform within 1 bit duration, I need to get the complete PN sequence. The PN sequence bit, number of bits in PN sequence is nothing but n. Okay, so can I write as TB is equal to TC by n? Can I write TC is equal to TB by n? Can I write TC is equal to TB by n? Are you understanding what I am trying to say here? Let me just explain you once again. So here what is happening, I have to spread the signal. Okay, if I want to spread the signal, I have taken B of T and I have multiplied with C of T and and I am getting M of T signal. Okay, and here if you observe, the B of T signal is taken in this way with bit duration TB, and C of T, whatever PN sequence is generated, okay, that PN sequence should generate whatever PN sequence that is generated, it should be generated within the 1 bit duration. Okay, so that is given by this. Okay, this whatever values I have taken here, it is nothing but the previous example. From the previous example only I have taken this. Now what I am doing, this C of T, if you just observe, within TB seconds, I need to get I need to get how many bit durations? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 TC. Okay, seven times of this TC, or I can write it in another way. TC is nothing but TB by 7, because within this TB seconds I need to accommodate 7 TC signals. Okay, so that is what means here. So TC is equal to TB by 7, or in general TC is nothing but TB by N. Okay, or TB by TC should be equal to N. So this PG is nothing but it is also equal to N. So I can write with this analysis that bandwidth after spreading will be equal to N times into bandwidth before spreading. Okay. I'll stop my class here. If anybody has got doubts here, you can ask me. So what will happen as N value increases, the bandwidth, the spreading will increase. Okay, as N value increases, the spreading will increase. Okay, as spreading is increasing, I am saying that you will be able to avoid the you'll be able to provide the security. As N value is increasing, what will happen? The bandwidth will increase. Bandwidth of the output signal will increase. As the bandwidth of the output signal is increasing, what we can do? We can provide the secure communication. How we are providing the secure communication? I'll show you by doing the frequency analysis. Okay, frequency domain analysis I'll do, and I'll explain you tomorrow. Until here, if anybody has got any doubts, you can tell me. Until here, any doubts? Or anybody want me to repeat anywhere? Is it clear? Is this clear? Okay. So tomorrow I'll continue from here. I'll explain how this spreading of the signal. Spreading in the sense, see, if I have the narrow band signal, this is my narrow band signal, which is nothing but here B of F. B of F is nothing but I'll get this B of F from B of T. Okay, after applying Fourier transform, this is what I'll get. This is the narrow band signal. Now what I'm doing, I'm spreading it. Okay, spreading it in the sense, this is what my M of F I'll get, because since TB is more, this width is less. This is FB or bandwidth. You can write it as bandwidth or FB, whatever it is. And now what I'm doing, I'm spreading it by using C of T signal. Okay, so this bandwidth is given by FC. Okay, FC is nothing but bandwidth of spreaded signal. Okay, so since I'm spreading it like this, I'm saying that I will be able to provide secured communication. So how exactly I'm providing the secured communication, I'll show you tomorrow. Okay, why spreading is required at the transmitter end, and how we are dispreading it, and what is the advantage of spreading, that I'll explain you tomorrow. See, whatever I'm doing now, it is all introduction. Okay, all introduction to spread spectrum techniques. Okay, that's all for now. If anybody have anything to talk to me, you can. Otherwise, you can leave the class. If you have any doubts, you can ask me. Otherwise, you can leave the class. The class is done for the day.
Thank you, ma'am.
Thank you.